Hello, everyone, and welcome to today's webinar, Sustainability Today for the Lab Tomorrow. I'm Christy Jewell of LabRoots, and I'll be your moderator for today's event. Today's educational web seminar is presented by LabRoots and brought to you by LabConco. To learn more, visit labconco.com. Now, we encourage you to participate today by submitting any questions you may have during the presentation. To do so, simply type them into the Ask a Question box on the left and click Submit. We will answer as many of your questions as we have time for at the end of the presentation. You may also use that Ask a Question box to let us know if you're having any technical difficulties. Today's webinar is educational and does offer free continuing education credits. Please click on the continuing education window at the bottom of your screen to obtain those credits. I would now like to welcome our speaker for today, Ryan Rios, Vertical Marketing Manager at LabConco Corporation. For a complete biography on Ryan, please visit the Biography tab at the top left of your screen. Ryan, welcome. You may now begin your presentation.
Welcome to Sustainability Today for the Lab of Tomorrow. I am Ryan Rios, co-lead of the LabConco Sustainability Committee. I'm very excited to discuss with you all today sustainability and its impact on your lab. Please comment and post your questions throughout our discussion today so that I can address those at the end. And if there's any follow-up, our team will love to hear from you. Email us at sustainability@labconco.com. Every purchase decision you make for your lab today impacts the story you'll tell tomorrow. This is because selecting equipment in the lab environment isn't like other decisions that we make daily. Think of it this way: the risk to purchasing the wrong version of the iPhone isn't going to waste you thousands in annual energy costs or increase the chances for lab workers to one day develop cancer. Making sustainable lab equipment purchases improves workers' safety and efficiency, the environmental impact, as well as the profitability of your lab. Today, let's review the concept of sustainability. What makes lab equipment sustainable, so that you know the questions to ask, so that you're sure you're making decisions today that will have a lasting impact on your lab sustainability in the future. Let's define sustainability for our discussion. Sustainability is a very complex issue with many factors to consider as you look to make the most responsible choice. While this issue of sustainability isn't new, especially in the science industry, we have seen a culture shift globally. More people are aware of these issues, and it's being measured and reinforced in ways we haven't yet seen as consumers. Organizations are now working to address the complex sustainability issues with specific targets, initiatives, and action items. All of this is excellent, but it's placed lab workers in the dark, placing the burden of being a sustainable purchaser on the consumers themselves without a framework for how best to make an impact and the right choice for their lab. I'm going to simplify sustainability and focus on qualifying your lab purchases using the 3 principles or P's of sustainability. People, that is, how does my lab equipment impact people? A sustainable product should improve their safety and efficiency. Most commonly associated with sustainability and well known of the 3 is planet. So what impact does my product have on the planet? Labs are inherently consuming, so a sustainable lab product will have a longer life cycle, contain more, and consume less. Least commonly associated to sustainability, perhaps, is profit. So we ask ourselves, how do these combine to improve the overall profitability of my lab? When choosing lab equipment for your application, there are often a million correct configurations. This further complicates the decision-making process for you. So not only has the world tasked you with being a responsible consumer, the lab has now provided you a million options for doing so. To make the sustainable decision-making process easier, let's break down these 3 sustainability principles for 3 types of equipment commonly found in the lab. Ventilation, any equipment that is used for the containment of hazardous vapors or fumes and ventilates air. To washers and water systems, so anything that washes glassware or provides you with lab-grade water. And then sample preparation as it sounds. So this is any equipment that is used in the preparation of samples. Each poses a unique set of challenges and solutions that you must consider as you work to make the most sustainable purchasing decision. So sustainability extends beyond its impact on the planet to the people themselves. And because of the high level of potential exposure risk in the lab and the highly technical and specific workflows, we must factor in the people themselves into our purchasing decision. Ask yourself, how can my choice of ventilated equipment impact people to improve their safety and efficiency? This is achieved by following the correct process to selecting your equipment, reviewing these decisions with all necessary stakeholders early and throughout the life of your lab design, and looking for built-in safety and efficiency features. New labs must conduct a comprehensive chemical hygiene plan and risk assessment per the authority having jurisdiction and all of the applicable laws, codes, and standards. Even if it isn't a new lab, this is going to define your materials of construction, your product specifications, and mechanical systems for all of your ventilation equipment to be sure that you have the best possible safety for your workers, and it is built to withstand their application needs of the future and optimize their workflows moving forward. You want to get everyone on the same page early and throughout the entire life of the lab design or project. These decisions must be understood and evaluated at each step. This is to engage stakeholders who might be separated from the design process and will lead to the most sustainable process and solutions. To learn more on sustainable lab planning and a breakdown of roles and responsibilities, as well as the relevant sustainable trends and goals for lab planners, please watch Solving Sustainability: A Look Inside the Lab. For those of us not designing new labs, you'll want to look for built-in safety and efficiency features. So is it ergonomic by design? And does it provide unobstructed work areas? So you'll want to look for aerodynamic airfoils that maximize containment and define workable areas so that users can operate more safely and with peace of mind. Also note a curvature in the design that provides comfort during long hours of work. On biosafety cabinets, you'll want to look for slots that ensure safe inflow of air and maximize containment should any portion of the grill be inadvertently blocked while the user is working. Note the curvature in the design, which builds that user comfort in so that they don't have to buy an additional armrest. Does it define workable areas? Let's take LabConco's exclusive Type C1 biosafety cabinet, for example. It is the first ever that can be used in recirculating A mode for standard microbiological work, or it can be connected to an exhaust system to function in Type B mode for handling hazardous chemicals. Unique Design's ChemZone is a large, clearly defined area within the enclosure that defines the safe area for handling chemicals to ensure the user's safety. On fume hoods, look for the aerodynamic curved foil that allows air to sweep the work surface, openings that pull the inflow air from under that airfoil. It forces air into non-turbulent streams to maximize the containment and user safety. Note the physical curvature of that foil. So it's not flat like other sills, and that is because it needs to define the working area for that user, so that they keep those chemicals contained in the interior of the hood and maximize their safety, and they're not setting chemicals outside of that containment zone. On all models, you'll want to look for safety glass sash that operates quietly and smoothly. It should not obstruct the worker's view, and so that they can work more safely and efficiently. Cord keeper slots can allow for workers to use that full working space really efficiently, and there are no cords that are getting in their way throughout the process. As you design a new lab, or even when you look to order a new piece for specialized workflows, consider color coding that equipment per their application. This will help to reinforce the safe use and proper operations per your chemical hygiene plan or risk assessment for that specific lab. Next, let's move on. How do glassware washers and water systems impact people in the lab, to improve their time and workflow efficiency. If you've spent any amount of time in the lab, you have used water to hand wash reusable labware. This is because it's found in almost every activity within the lab, from holding samples to preparing reagents and buffers and measuring liquids. Many of you probably see washing labware as a mandatory part of lab life. It's inevitable. But what starts as a simple task quickly becomes time-consuming and messy, and an extreme burden at the end of a long day, particularly when these spaces are shared or if their application produces a lot of soiled pieces. So look for built-in intelligence and lab-grade configurability and quality. LabConco glassware washers feature an operating system to automate processes and parameters for daily repetitive tasks. The 5-inch touchscreen display is user-friendly and provides them with full control of their washer. Ask yourself, is it programmable? With 10 programs included on LabConco glassware washers to set lab workers up for success from day one. Let's say they only need to rinse or dry, or they want to choose from common lab materials or applications, such as plastic or glass, or life science and analytical. They can choose all of these things. They could also select extreme for tough dried-on contaminants or eco for light duty. These are all pre-programmed by LabConco for the specific application needs of the lab. Users can easily create and store 200 more custom programs, giving them intuitive control of their washer to automate cycles, freeing more time up for meaningful tasks. Ask yourself if it's configurable and does it support the many applications of all workers now and in the future. This is why LabConco glassware washers can handle over 5,000 configurations of labware and all types of lab-grade water. This is to support the wide variety and robust application needs of the lab. It's built to accept any of the glassware you might see, such as volumetric flasks or pipettes, as well as test tubes and beakers, and dry them all effectively in one load, saving users valuable time. You might consider under-counter glassware washers, similar to what you'd have at home, and wall-mounted water systems. These both could be used to save floor space and free up working counter space for the users. Be sure that accessories and systems are working together to improve workers' efficiency. So does it really have enough options for the complex workflows in the lab, with the ability to maximize throughput with its accessories that are tailored for that glassware washer? This includes the right type of water for their applications. Otherwise, they may be wasting unnecessary time on replacements and maintenance and unnecessary hand washing. Let's end our discussion today on the potential impact on people with another common workflow of any lab: sample preparation. Because scientific measurement is only as good as the sample preparation that precedes it, it's a key component of many workflows. It's also very, very time consuming. But as such an important step in our scientific analysis, why would we take a risk? So ensure that workers have built-in intelligence and safety with the configurability they need for their workflows with lab-grade quality and accessories. You can look for operating systems to automate sample run efficiency. This will eliminate the guesswork for users and prevent excessive run times per batch. They'll enjoy a more efficient use of their equipment with easy-to-use touchscreen controls, sample monitoring and program storage, and they can stay updated every step of the way, in or out of the lab, with optional email alerts that will notify them when their endpoint is reached. Also, look for heat and runtime programmability to maximize their throughput, with built-in features to keep analysts and equipment safe. This includes automatic locking mechanisms and fail-safes. Fail-safes will notify the users when operation or equipment malfunction to allow the efforts that they use to produce that sample to be preserved, instead of finding out that their samples were damaged during their run and that they need to start all over. So is it configurable to support the many application needs for all workers to maximize their throughput? LabConco's freeze-dry line has ice holding capacity from 2.5 liters all the way up to 18 liters. This allows for multiple runs without the need to defrost in between. The accessories support samples from microliter all the way to liters in size. The shelf processing areas are up to over 1,000 square inches. And PTFE coating is available so that you can freeze dry any type of sample, even corrosive substances, providing over 60 interchangeable accessories to accommodate the widest variety of applications with simple plug-and-play intelligence. With LabCongo's concentration and evaporation line, you're able to produce a high throughput of samples efficiency from low volume to high and biological or non-biological. It ensures the efficient production of many small samples. And you want to also ask yourself if accessories and systems are working together to improve worker efficiency. And is it the right solution for the complexity of lab workflows and applications? From ventilation all the way to washers and water and sample preparation, ask yourself if this is the best possible solution for lab workers' safety and efficiency and their specific application needs and workflows. When consumers hear sustainability, they often think of some form of environmental impact. But what you may not know is that we as lab consumers carry a lot more weight on our shoulders because the lab, unlike the home or the office, consume a substantial amount of natural resources. For example, the global research enterprise, which consists of millions of labs, consume on average 5 to 10 times the energy per square foot of similar sized structures. Labs with large process loads or clean rooms, for example, can consume as much as 100 times the energy of similar sized structures. So let's discuss how you can make an impact on the planet with every purchase. Sustainable lab products will have longer life cycles, contain more, while consuming less. Ventilation products account for a large portion of total lab energy consumption. In fact, one chemical fume hood can use as much energy as 3.5 homes every single day due to the large volume of air that must be moved through the hood by the ventilation system. So you're going to want to look for proven containment. This is why LabCongo built its airflow test lab with the ability to control every single element of the room, from temperature and air quality, all the way to supply air volume and location, all of it from a computer, with the capacity to exhaust air volumes up to 5,600 CFM, and the versatility to test small and large equipment, all the way from 2 feet to 16 feet ducted benchtop and floor-mounted hoods. LabCongo engineering teams create, enhance, and precisely test features in order to gain high performance at lowest operating cost as measured in CFM and incoming face velocity for all of our ventilated equipment. With the greatest versatility in technology, we're able to push our product development to the limit. Let's take a look at an example. Before finalizing the design of our high performance fume hoods, our engineers tried over 50 airfoils. This resulted in a 7 to 10% reduction in energy consumption compared to flat foils. They tried over 50 baffle combinations to lower the required average face velocity needed, decrease the resistance to the entry air, and promote horizontal airstreams, maximizing containment. And 24 sash handles to ensure that the airflow was swept into the hood with minimal turbulence, and the slots on the sash tracks of the corner posts enhanced airflow. Another thing that LabCongo does differently is that we test our products to validate our designs throughout the human body. So what I mean by that is that we test our products with tracer gas at additional probe locations. So for example, at the chest, right in that breathing zone of that operator, so that we can validate that there is no potential hazards for that user and they operate at their optimal safety. So we test our products this way to be absolutely certain that we have unrivaled containment at the lowest possible energy use. But don't take our word for it. Ask your manufacturers to share their third-party test reports, because this attention to detail in our own product design allowed our hoods to be tested per the National Institute of Health protocol to an ASHRAE 110 as manufactured high performance containment rating of as low as 0.000 parts per million of tracer gas detected outside of the hood, with a lowest detectable limit of 0.001 parts per million. Choosing ventilation equipment that is proven to be better by design will not only result in improved energy consumption, but it will also lead to longer life cycles. So look for durable construction, features such as LED lighting, which lasts longer, and materials to match their application, per their chemical hygiene plan and risk assessment, all of which are specific to their lab and needs. This will ensure a greater total life cycle. There are also incentives for making such responsible choices for your lab. So the United States Green Building Council's Leadership in Energy and Environmental Design, or LEED, allows you to earn credits for operational efficiency and longer life cycle of your products. So ask your manufacturers about percentage of recycled content, which is focused on the pre-use content and what that product is made from. Then you're also going to want to ask them about percentage of recyclable, which focuses on the post-use content and how much of that will recycle after the product's useful life. LabConco fume hoods are built with over 40% recycled materials, with 70% of the materials being recyclable after its useful life. So this will earn you credits for energy and atmosphere, materials and resources, and innovation and design. The same LEED credits can be applied for our biosafety cabinets, which are made with over 55% recycled materials, and 95% of the materials are recyclable after its useful life. Less filter replacements are going to be required over the life of your products because you've conducted or referenced a thorough chemical hygiene plan and risk assessment specific to your lab to determine the best possible equipment solution for your lab's needs today and in the future. Do not forget to factor in the cost up front of filter replacements and maintenance, because over time, those things can add up. Because of the large consumption of water by labs, efficiency and conservation are going to be key. So let's review the impact washers and water systems may have on the planet. Choosing lab-grade systems result in longer total life cycles, better lab efficiency, and reduced water consumption. Think of your home dishwasher or water filter for your tap water, except for these are going to be much more robust for all of the flexibility, configurations, and sizes needed for the lab, with washers that are built for purified water input, whereas your home washer is only able to accept tap water. Using quality lab-grade water works to extend the life of all of the products in the lab. Also be sure to look for efficiency features to improve cleanability, such as dual pumps. So your washers at home only have a single pump, one to pull water in and wash all your dishes, and the same one that pulls it all out. In a lab-grade washer, you're going to have two. So one pulls water in and one is going to expel the water out. The reason this is important is because it will avoid cross-contamination. These units for the lab are also very, very powerful and can get very hot, up to 199 degrees Fahrenheit. They have other built-in efficiency features specific to the lab, such as durable construction to withstand harsh chemicals and hazards, and a system to measure your water conductivity that allows for the bypass of unnecessary pure water rinses, as well as HEPA filter drying for particulate-free drying and steam generation for tough dried on contaminants. LabConco glassware washers are also going to lead to reduced water consumption overall, and they don't just save time compared to hand washing, which on average uses 20 gallons to wash only 30 pieces. Systems that you choose should use less energy and power by design. Our glassware washers, for example, reduce the consumption by up to 40%, and this translates into potential LEED credits and reduced impact on the environment. So it's built with about 51% recycled materials, and after its useful life, 78% of those materials can be recyclable. You are able to earn LEED credits for materials and resources, as well as innovation and design. My only last note here will be that you ensure that these glassware washers and water systems are working together to maximize the efficiency and total water consumption. Sample preparation is a consuming workflow that involves a lot of single-use plastics, reusable labware, and many parts and pieces. So you're going to want to look for longer life cycles and lab-grade systems that consume less energy and are less harmful by design to the planet. This will result in an extended service life. So how do we maximize our life cycle of our products and parts? We will do so by ensuring durable materials of construction that match the rigorous applications of the lab. So you want to look for powder coating in stainless steel construction, PTFE coating on collector chambers to resist corrosion, wear-resistant quick disconnect drain hoses. And it's also going to include built-in pump protection because pump damage can be very expensive and really slow you down. So you're going to want to look for a drain line sensor, such as LabConco's, that detects moisture before it can damage your pump. As a result of being better by design, LabConco freeze dryers are built with over 47% recycled materials, and 85% of those materials can be recycled after its life. Believe it or not, there are many perks to choosing lab grade over your random home system. Because the application needs have dictated our product specifications, these systems are designed for the lab, from the system all the way down to the parts. Researchers easily can change from one methodology to another with a simple swap of their accessories. It integrates with reusable labware instead of wasteful single-use plastics, as well as consumes less energy by design. LabConco freeze dryers preserve samples for storage at room temperature, and shelf-stable freeze-dried samples can eliminate the need for consuming ultra-low temperature freezers. They're also less harmful on the exterior air that we breathe with CFC and HCFC-free refrigerants. You can use a cold trap to capture environmental contaminants instead of exhausting them into the air, or choose a scroll pump over other popular vacuum types, as they consume 50% less of the power and generate 50% less heat. It removes all of those hydrocarbons from potentially contaminating all the other samples in the room, and they don't require consumable oils that other pumps use. Choosing equipment for the lab that is better by design results in improved total life cycle of your products that contain more and consume less for an overall greater impact on the planet. So let's now break down how these decisions may impact the profitability of your lab. The cost to temper air that is required for this ventilation equipment is substantial. So be sure to look for energy cost savings in the form of lower face velocities and the lower air volume required, as measured in CFM at those incoming face velocities. You'll want to remember to factor in filters and replacement costs for the life of the product up front, as they can add up. For washers and water, you're going to want to factor in potential time and energy savings, as well as longer total life. Is it set up to automate efficiency? Does it save not only in water consumption, but also hourly wages? Similar to the cost of air, water costs vary drastically per location. So ask yourself, does it reduce water consumption by design? With the robust design and materials of construction needs that you require for your lab, use the LabConco glassware washer calculator to evaluate your potential savings and set your own parameters for days per week in operation, number of pieces washed, hourly wages, down to number of rinses and water type. Sample preparation systems need to be lab grade in order to lengthen their total life cycles and maximize the efficiency in time and operation. So look for time savings and hourly wage savings with interchangeable plug-and-play accessories and lab-grade quality so that you don't need to purchase additional products over the life of equipment. Look for long processes which can be automated. For example, LabConco freeze dryers can save users up to $1,000 per year versus running a ULT freezer. The reliability and total lifetime of the product is important. Less downtime for maintenance or service equals more throughput and higher profit margins. So let's take a look at one high-level case study example. Children's Mercy Research Institute. a research facility servicing 367 hospital beds with 410,000 square feet of dedicated research space. They had many goals in mind at the beginning of this project. They wanted to create a research hub with flexible lab spaces as they began construction before much of their research was solidified. They also needed comprehensive GMP suites for advanced gene and cell therapies. They wanted to maximize their energy savings with a mechanical system and lab equipment designed for the best possible safety at lowest possible energy use. They needed it to withstand the rigorous application needs and optimize their workflows for the lab of the future. The energy savings they received was up to 56% in CFM by switching from the Type B2 biosafety cabinet to LabConco exclusive Type C1. This meant a smaller mechanical system by volume with lower static pressure requirements and a dedicated exhaust system per B2 cabinet no longer needed. They also employed LabConco's exclusive fume hood with third-party test ratings of 0.000 parts per million tracer gas detected outside the hood for $140,000 in energy savings annually for LabConco fume hoods at $5,000 per unit in CFM savings times the 28 units. One glassware washer saved them approximately $5,399 per year over hand washing, and they were able to save annually $319,079 in energy savings with the ability to maximize their ultimate exhaust diversity calculation. There's a little bit of everything in this lab, all the way to non-ventilated products for their workflow and research. So remember, the most sustainable choice is also the safest and most efficient for your lab and its users. And in the end, it's also the most cost-effective solution. Making sustainable purchases for your lab is hard and confusing, but you can make a difference by not only qualifying your purchases across the 3 principles of sustainability, but also choosing manufacturers and products with embedded sustainability in their products and operations. You can select the best possible equipment for your lab workers, the environment, and dollar savings. If you have any questions or would like to learn more about our action plan, please contact us. We are interested to learn more about you and your interests and how we might support you. Or if you're interested in a consultation on sustainable products, we'd love to discuss your solution. Email us at labconco@sustainability.com. Thank you so much.
Thank you, Ryan, for your informative presentation. We will now start the live Q&A portion of our webinar. Now to our audience, if you have any questions you would like to ask, please do so now. Just type those questions into the Ask a Question box and click Submit. We will answer as many of your questions as we have time for. Okay, Ryan, let's get started. We have quite a few questions already coming in. Let's start with this one. Why do I need to look for lower face velocities and required air volumes at those face velocities?
Yeah, that's an excellent question. Thank you, Christy. This is a really important question to ask yourself as you look to select ventilated equipment, any sort of enclosure that ventilates into that lab. The reason that this is an important key to look for is that there is a relationship between face velocity, exhaust volumes, and operating costs. So in general, think to yourself, lower equals less dollars. Because not all fume hoods and biosafety cabinets are made alike, and every lab is going to have its own unique ventilation requirements in the form of air changes per hour. So that is the number of times that we must move that room's volume of air out, as it is specified in the chemical hygiene plan and the risk assessments for your lab. We do this because we need to ensure that there's enough air in that room and we're not starving workers of oxygen, as well as we've properly ventilated it for their application requirements. And that is to keep and think of it this way, keeping that air safe and of high quality, and so on. Now, remember, earlier I said one chemical fume hood consumes as much as 3.5 homes daily. That's because of the large volume of air that must be moved through that hood by the ventilation system per hour. So if we look at the average 6-foot fume hood operating at 100 feet per minute face velocity with the sash fully open, that's going to consume 70,800 cubic feet of air every single hour. And air is very expensive. So on average, that would be $8,260 per year to operate. But air is very expensive, and the cost to temper it varies drastically per their location. So if you're in California where it's 87 degrees, that's going to cost you substantially less than where I'm at in Kansas City today, where it is 47 degrees. So we have to ask ourselves about the lower face velocities and required air volumes at those face velocities in order to ensure that we are keeping workers as safe as possible with the best possible containment and ensuring efficiency by the way of lowest possible energy use.
Brian, thank you. Our next question, and it is 2 parts. How do I select the right glassware washer for my application? And how does it conserve water compared to hand washing?
That's an excellent question. I'm going to start with the conserving compared to hand washing. So as I mentioned earlier, hand washing 30 pieces of labware takes about 20 gallons of water. Well, quality glassware washers should use less than 13 gallons of water to wash that same amount of labware, which translates to about 1,664 gallons of water per year. But like air, water costs vary drastically per location and will add up quickly. So a quality glassware washer is going to save your lab money and be much better on the planet in terms of water conservation. But there are also going to be, for your application specific needs, many considerations to keep in mind. I would say that in general, because of labs being so dynamic and fast-paced, and because of workflow and research needs changing rapidly, you're going to really want to look for built-in versatility so that the end users can quickly respond to changes in standard operating procedures for the lab, and also that it has the high performance that it will need to clean the specialized glassware you might see, from volumetric pipettes or specialty bottles to graduated cylinders.
Thank you, Ryan. And it looks like we have time for one more question. For sample preparation, what are some of the differences between lab and home models?
Yes, that's an excellent question, because the general lyophilization concept and workflow is the same, but the biggest difference there will be your results. Home freeze dryers are usually all-in-one models, and they're built to preserve berries, food, things that we eat. The lab freeze dryers have much greater capacity and components that are built to preserve samples for very important research and testing. Much more expensive samples than, berries, for example. It's going to have additional capacities. You're going to have additional controls, such as temperature controls, as well as programmability that the lab workers are going to need for such intense workflows that they face, and as well as the flexibility that they'll inevitably need as their research evolves in the future. And then while, of course, that upfront cost is going to be higher, I'll just point out it'll pay itself back over the life of that product because of its longer life cycle. And you're going to have scientists and researchers now able to change their methodologies by simply swapping out an accessory versus just having the option of shelves.
Thank you again, Ryan, for your time today and for your detailed information on sustainability today for the lab of tomorrow. I would like to thank LabRoots and also our sponsor, Lab Congo, for underwriting today's educational webcast. Before we go, I would also like to thank the audience for joining us today and for their interesting questions. We did have a few questions we weren't able to answer, so those and the ones submitted during our on-demand period, they will be addressed by the speaker via the contact information you provided at the time of registration. Today's webcast can be viewed on demand, and LabRoots will alert you via email when it's available for replay. We encourage you to share that email with your colleagues who may have missed today's live event. Thank you for joining us today. Have a great day.